Hello, Wayland Middle School. It's Mr. Farley here. I'm going to be showing you how to divide exponents here today. And you've seen a lot of these charts here during the week in the other videos that Mr. Robinette was working on and helping you learn how to multiply exponents. Well, today we're going to divide exponents. I want you to pay close attention here to this section. I have a 10 to the fourth power, which can be written as 10 times 10 times 10 times 10. I think everyone's pretty clear about that. Division, we could write that as a fraction bar. So I do like to put it over 10 squared, which is a 10 times 10. So I'm going to kind of ignore this other stuff over here to the side for a minute. And guys, we can cancel a couple of these 10s, and it doesn't matter which one you cancel. Maybe I'll cancel those two and those two. I think if you look, we have a 10 times a 10 in the numerator, and everything's been wiped out in the denominator. So it's really over 1. So 10 times 10 is 100, and I can write it as an exponent as 10 squared. We know 10 squared to equal 100. All right, so this guy here, I'm just going to look. Let's count. We have 1, 2, 3, 4, 5 10s that are repeatedly being multiplied. I could write that as 10 to the fifth. And now I'd like to divide it by 10 times 10, which is 10 squared. So that's the expression we're starting with. And just like the previous problem, I can cancel any of these. I have a 10 upstairs and a 10 downstairs. That's pretty good. I have a 10 times a 10 times a 10, which is 1,000, but I could write that as 10 to the third power. All right, so that equals 1,000. This guy is a 10 to the sixth, so I can write that as 10 times 10 times 10 times 10 times 10 times 10. And it's being divided by, so I put it over 10 to the third, which is a 10 times a 10 times a 10. And now, guys, I can cancel again. See you later to you, and to you, and to you. And I am left with 10 times 10 times 10 in the numerator, which we know is 1,000. And 1,000 can be written as 10 to the third. So these all make sense, all right? These are nice small numbers, easy to work with. This example here, numbers are pretty bad. So wouldn't it be pretty cool to have a rule for dividing exponents that would be similar to the rules that you learned about multiplying exponents? Well, the good news is there is a rule. And the rule for division is if the bases are the same, and the bases are the same. In all of these examples, the base is 10. But right here, base of 10, both of them. Here's a base of 10 and a base of 10. I can rewrite the base. And if you noticed, if I take these exponents, 4 minus 2 gives me 2. 5 minus 2 gives me 3. 6 minus 3 gives me 3. And 43 minus 17 gives me 26. So guys, no one wants to multiply this out. No one wants to expand 10 to the 26. That would be 10 times 10 times 10, 10, 10, 10, 10, 10, all the way through. No one wants to do that. That's why we can write it as a single power, 10 to the 26th power. So this rule, the rule of division, is when dividing, if the bases are the same, you want to keep the base and subtract your exponents. One last example right down here. If I have a 4 to the 20th being divided by 4 to the 13th, think about it for a minute. Are the bases the same? They most certainly are, so I'm going to keep the base and now subtract my exponents. 20 minus 13 is 7, and you just wrote this expression right here as a simplified single-powered exponent of 4 to the 7th. So guys, as usual, if you have any questions, please feel free and reach out by email. Mr. Robinette will get back to you as soon as possible. But hopefully this rule for division of exponents makes some sense to you. And I think that's it. So signing off from here, and we'll catch up with you soon. Take care, everyone.